All right, people, here we go. I'm going to show you how to do all of these problems from our homework assignment from last night. So remember, I checked off how much you got done by the time you came to class. That's part of your grade. And then you're going to go through and make corrections. It would really help me out a lot if you would make your corrections with like some kind of colorful pen or colored pencil or something so that I can see what it was that you changed as we go through. But yes, you're going to copy down my work and the correct answers if you need to fix them from what you had. So here we go. Number one, 10 grams of water and 1 kilogram of 30 degrees Celsius air. So all of the values in this table are for 1 kilogram of air. So since we have 1 kilogram of air, we can just use the value straight from the table. So we have 10 kilograms, or we have 10 grams of water. If we've got 30 degrees Celsius air, a kilogram could hold 26.5 grams. So 10 divided by, let me grab my calculator. 10 divided by 26.5 gives us 0.3773. To get it into a percentage, we do times 100, and so we get 37.7358. In the directions, it tells you to round to the 10th, so our answer is going to be 37.7%. 37.7%. Because it's a relative humidity, it's in percentages. Next, number two, we have 0.6 grams of water. In a kilogram of 10 degrees Celsius air, we could have up to 2 grams of water, so 0.6 divided by 2.0 on our calculator. 0.6 divided by 2 equals 0.3 times 100. We get 30%. We want it rounded to the 10th, so we're going to put 30.0%. Question number three, now we have 13 grams of water. Now this is where it gets tricky because we're working with 500 grams instead of a kilogram. So 1 kilogram of 40 degrees Celsius air could hold 47 grams of water, but since we've got half of a kilogram, 500 grams, we're going to have half this amount that can be there. So half of 47 is 23.5. But from here it's the same. We just take 13 divided by 23.5. We get 0.5531 whatever times 100. We get 55.32%. Say 55.3 because we're rounding to the tenths. Okay, next, now we have 2.5 grams of water. Same deal, we've got a different value. So now we have 250 grams. That's 1/4 of a kilogram. And so we go up to 20 degrees Celsius in our table, which is 14. We've got 1/4 of that, so we just take 14 divided by 4 on our calculator, which is 3.5. So we have 2.5 out of a maximum possible of 3.5. Same process from here, 2.5 divided by 3.5 times 100 is 71.4. Okay, so now moving on to number 5. How much water would be required to saturate 500 grams of 5 degrees Celsius air? So in this case, we can look up at our table, 5 degrees Celsius air, a kilogram of it takes 5 grams. And then we're going to divide by 2 since we have only half of the amount. Remember, this is for a kilogram and we've only got half of that amount of air. So 5 divided by 2 gives us 2.5 grams of water vapor are required to saturate 500 grams of 5 degrees Celsius air. Next, so now we've got 25 degrees Celsius air. 25 degrees Celsius air can have 20 grams in a kilogram, and now we've got 250 grams. 250 grams again is 1/4 of 1 kilogram, so we're going to divide by 4. Not 4 grams, just 4. Overexcited on my labels there, so then we end up with 5 grams is our answer for this one. Okay, on to the next. Question number 7, how much water would be required to bring 1 kilogram of 15 degrees Celsius air to 60% relative humidity? So 15 degrees Celsius air at 100% can hold 10 grams. We want 60% of that, so we take 10 times 0.6 on our calculator. If you did it on your calculator, you'll get 6.0 grams. So it would take 6 grams to saturate a kilogram of, or to bring a kilogram of 15C air to 60% relative humidity. Question number 8, how much water to bring 500 grams of negative 10 degrees Celsius air to 45% relative humidity? Okay, so now we're going to be looking at this negative 10 Celsius air, negative 10 Celsius air can have 2 grams at saturation for a full kilogram, okay? But we've only got half that amount, so we're going to divide this by 2. So 1 gram total would be at 100% relative humidity. Well, we only want 45% relative humidity, so we'll take 0.45, and we get 0.45 grams. 0.45 grams of water vapor is required to bring 500 grams of negative 10 degrees Celsius air to 45% relative humidity. Okay, so now moving on to number 9. If the temperature of saturated air at negative 20 C was raised to 10 C, what would be the new relative humidity? So we got to start with the saturation of the negative 20 C air. So negative 20 C air is saturated with 0.8 grams of water vapor. Okay, so that's how much we had to start with. So now we're going to find how much is required to saturate air now that it's at 10 degrees Celsius. 10 degrees Celsius air requires 7 grams. So we have 0.8, we could have 7 at our new temperature. So now it's just simple division from there. If you take 0.8 divided by 7 times 100, you get 11.4%. Okay, and now the second part of the question, would condensation form at the new temperature? So condensation can only form if you have 100% relative humidity, or maybe even more, right? So we don't have that, so no condensation can form because the humidity is too low. Next, so now we've got 55% relative humidity air that's at 35 degrees Celsius, and it's lowered to 20 degrees Celsius, okay? So let's find out what is 100% relative humidity of 35 C air from the table. So that would be 35. So 35 would be 100% relative humidity. We've only got 55%, so we're going to take 35 times 0.55 to get the 55%. 35 times 0.55, we get 19.25 grams. That's how much water vapor is in 55% relative humidity air at 35 degrees Celsius, okay? And so now we're gonna say the temperature was lowered to 20 degrees Celsius. What is the relative humidity now? So now we gotta figure out how much saturates 20 degrees Celsius air. Go back to the table, 20 degrees Celsius air is saturated at 14 grams. So we're gonna take 19.25 divided by 14 grams. Times 100, we get 137.5%. That's above that 100% mark, so yes, condensation could occur. The second part of the question, yes, it could occur because it's above that 100%.